And I want you to practice. I'll do another demo of this in a little bit, but it's the same thing as the cube, as drawing the cubes. You kind of ghost it for a bit, and then you put down your pen. And I'll show you some other tricks too, but you're basically going to go like this. And practice drawing them. I'll show you more later. Everyone look at this and look at how these are different percentages. 8%, 17%, 26, 34, 42, half. What that's saying is, at 30 degrees, a 30-degree ellipse is half as tall as it is wide. Okay, these are worth remembering. And I'll show you why in just a second. All right, so you guys, now let's say we have a picture. Actually, let me just do it. Let's say we have an eye level like this. Oh, actually, I just realized I need to show you something else first. You guys, here's the quick history of you guys drawing ellipses. Okay, this is how everyone learns how to draw ellipses. The first thing is they do this. Okay, that's when people first start drawing circular objects, that's how they do it. Okay? Now, if then some well-meaning uncle, older brother in my case, someone like that, comes along and starts to, no, it's not a circle, it's an ellipse. So they go like this. You draw an ellipse.
Oh, yeah.
Okay. So then the next step is someone goes like this. Okay, and that's where most people are.
Yeah.
And they're still wrong. And the reason they're still wrong, can anyone tell me? Actually, Sam.
The bottom ellipse is receding into space at a different angle than the top ellipse.
Actually, well, they're the same, actually, which is the problem.
Yeah.
So you have the same degree. When I say the degree of an ellipse, I'm saying how thick it is. So this is a 0 degree. You guys, this is a 0 degree ellipse. Okay, a line. You're seeing it, right here, and this is a 90 degree ellipse, which is a circle. All right, so halfway in between, like say that's like about a 30 degree ellipse, and you have 60 degree ellipses, etc., etc. Okay, so what you're saying is I'm looking down on it at this degree. Straight down, 90 degrees. Straight out, 0 degrees, 45, 30, 10. You see what I mean? Now there's something that I want to, this is the best way I can explain this to you guys. So anyway, so you guys, all the degree is saying is the degree to which you are looking down on an ellipse. That's all. So 0 straight out, 90 straight down. Okay, now anybody in here a baker? Okay, Sam. All right, I want you to do something. I want you guys to watch Sam carefully. Okay, Sam, I want you to imagine you have to measure 3/4 of a cup of milk to put in a cake or something. And mime that action. Mime like pouring the milk into the measuring cup and all that. Okay? Yeah, yeah. So what you're doing, when you do this, you're doing this to eliminate the ellipse.
Make sure it's, yeah.
You're bringing it to your eye level. Okay, now I think that's an important thing to tell you guys about because that's what you need to understand about drawing ellipses. The degree of the ellipse is dependent upon its distance from the eye level. Does that make sense? So if you have 2 ellipses like on a coffee cup, there is no way they're both the same distance from the eye level unless it's bisecting it. That's the only case where they will be the same. If you're looking down on the coffee cup, the ellipse that's further from the eye level will be fatter. Yeah?
This is for the example, when you take like a biology classes, you are always think like a beaker or something, put the eye level.
Yeah.
That's like a example for that.
Yeah, it's the only way to measure it. Because otherwise you're screwing up the measurement. Now, so you guys, so what you'll have is you'll have something like this. You'll have a 0 degree ellipse, and then a little bit below the eye level, you'll have a very skinny ellipse like this. A little further down,
This brings us back to the dead space concept, right?
yes. So here's something that you guys don't fully appreciate yet, but I'm just going to tell you this as a hint. Anytime you draw an ellipse, you know how when you drew that first cube in your picture and you establish all your perspective?
Yes.
The same thing happens when you draw an ellipse. You not only establish rotational things with a cube. With an ellipse, you establish the eye levels, the distances, all kinds of things. And when you have both established, if you can draw a cube with an ellipses on it, your whole perspective framework is defined. And so if you can draw a big cube on a page, you can now draw any object with those orientations all established. Does that make sense? It's pretty potent stuff. But you have to know what you're doing. You have to know how to draw the ellipse correctly and how to make it look symmetrical and all that kind of stuff. Now, the thing I was talking about with the degrees, on that other page, where you saw like a 0 degree ellipse, okay, equals 0, obviously. But a 5 degree ellipse, I'm doing this off of memory, is approximately 8% as tall as it is wide. All right? And I'll show you where I'm going with this in a second. A 10% ellipse is, I think, 0.17, so 17% as tall as it is wide. The 15 degree is, I think, 0.24. The 20 degree, I think, is 0.34. The 30 degree is 0.5. Now, why am I doing this? Because I want to show you a really simple kind of thing that you should memorize. All right? Yeah, Pat.
Are those those are on the worksheet, correct?
Yeah, those are on the worksheet, but here's the shortcut I want you to memorize. Because most of the time when you're doing this, you're going to be doing this out of your head. Okay, you're not going to necessarily remember 0.74 or 0.14, you know what I mean? It's going to be hard to remember the decimals. So here's what I want you to notice. A 30 degree ellipse is half as tall. Wait, everyone keep your eyes up for a second, I'll give you a sec. So that's half as tall. Now notice, we go to the 20 degree, a third as tall. Keep watching. A quarter, a fifth, a tenth. So if you remember that, okay, it basically steps down, half, third, quarter, fifth, tenth. You basically own all the ellipse degrees from 30 degrees up. Now here's the other reason that's important. Most of the ellipses you draw are going to be 30 degrees and up. There's not going to be that many. The reason there's not going to be that many from 30 degrees to 90 degrees, two reasons. One, they don't change much. Okay, think about it. You've got 2/3 of the degrees, but only half the change. You see what I mean? So that's one reason. The other reason, most of the ellipses we draw are parallel to the ground plane. If they're parallel to the ground plane, unless we're doing aerial views, we're looking out at this angle. So we don't even see ones that are closer than that, unless we're looking down. Does that make sense? The only time we see them is when they're like a side cylinder, like a cylinder laying on its side. Then we'll have fatter ellipses. But usually all the ellipses that are on the ground plane, we see them between 0 and 30 degrees. Now, here's something that I want you to understand. Let's say I do a picture like this. Okay, and I go like this to it. I can't guess at my eye level anymore. You see that? I've established if that's a, if I measure this, okay, that to that, okay, that's about a 15 to 20 degree ellipse. So I know my eye level has to be a certain distance up here. You see what I mean? So this is really important that you understand this kind of stuff, because these ellipses you're drawing on, say, a coffee cup are not arbitrary. Now here's the other cool thing about it. Let's say you're drawing, everyone find something around you that's elliptical. And look at the top of it. Now you guys, take a pencil. You guys take a pencil and measure the width. Do it with a straight arm so that you're not going like this, But measure the width. And then, if you have the CD, lay it on a table so it's nice and flat. And back up from it. So you guys measure the width, okay? Now compare the width to the height by going like this. What percentage is it? Is it half as big?
Yeah.
Now visualize where you are. Are you looking down at about 30 degrees to it? Yeah, if it's half as big. Rachel's gonna be laughing about it. That's 30 degrees! Our roommates are going, Rachel's lost it again. Now you guys, do you see what I mean? So this is potent stuff. So the first thing is this. Here's the little diagram. So here's Perspective Boy. You guys haven't met Perspective Boy yet, you will. But that's Perspective Boy. Now, here's a circle, here's a manhole he's looking at. All right? Now, what you're doing is you're looking at the center of it, you're saying, okay, all right, this is about 25 to 30 degrees, probably about 28 degrees. So when he sees that, he's going to see this projected onto the ground plane like this.
Whoa.
Okay? And it's going to be a 28 degree ellipse on his picture plane. All right? That's why when you say in perspective, it kind of is a nonsensical question, because ellipses are never in perspective. There's something that happens on the picture plane. So I don't know if that answers the question or not, but.
I was giving a question.
Okay. Well, did someone have a question? Sam, did you? Okay. All right. So anyway, so that's the